हेलो गुड मॉर्निंग ऑल ऑफ यू। गुड मॉर्निंग ऑल ऑफ यू। कैसे हो आप सभी? हाउ आर ऑल ऑफ यू टुडे? गुड मॉर्निंग ऑल ऑफ यू। Good morning and welcome to this second session, second week of the English lecture series on group theory. Okay, so we have learned what point groups are. We have learned what different kinds of symmetry operators are. Now in this class we are going to learn what the various applications of these point groups and symmetry operators can be in studying or while studying molecular properties like selection rules in vibrational transitions or even electronic transitions, as well as whether a particular vibrational mode is IR active or Raman active. And in today's class, what we are going to see is two main applications of point groups, which is polarity and optical activity. Okay. Uh, Good morning, Ayers Deb. I think आपका नाम है. I'll call you Deb. Good morning. Thank you so much. Thank you so much for the compliments. Bhargavi, good morning. Good morning. When will the admit card come? Admit card will come after the 20th. Don't even think about when the admit card will come. Right? It will come where it will come. Yeah, if you keep worrying about it, it's not going to help you crack the CSIR net exam. What is going to help you crack the CSIR net exam is revising and practicing PYQs and solving a lot of practice tests. Good morning, Ankita. Good morning. All right. So in this class, what we are going to discuss is polarity and optical activity. Okay, polarity meaning whether the molecule has a dipole moment or not. Optical activity means whether it is going to rotate the plane of polarized light or not. Okay. All right. So before we do that, let's quickly revise all the different types of point groups. All right. Deb is saying, I learned group theory only from your videos. That's great. That's great, Deb. Okay. So, there are different types of point groups. There are four main types of point groups. One is low symmetry, the other is high symmetry, and the third one are special symmetry point groups. And the fourth one is a full rotation point group, which is only for spherical molecules. Okay, that point group is called as R. Okay, now in each of these point groups, you will notice something that is written here. Okay, for example, the moment you see C1, this 1, the numerical subscript, talks about n-fold rotational symmetry, meaning if it's a point group called C1, then it has a C1 axis, meaning the identity operator. If you look at this particular point group CNV, it means that it has a Cn principal axis or a rotational axis. So for example, if you have a C4V point group, okay, if you have a C4V point group, the 4 in C4V corresponds to a C4 rotational symmetry. All right. Then these alphabetical subscripts V, H and D, okay, these alphabetical subscripts V, H and D, they talk about reflection symmetry. Okay, so for example, look at this point group CNV. The moment you see a V there, it means that it has a sigma V, meaning a reflection symmetry, a reflection plane which is parallel to the rotational axis or parallel to the principal axis. All right. CNH here. The H here stands for the horizontal plane of symmetry, sigma H. Whereas the DND here, the D stands for a dihedral plane. Okay, a dihedral plane of symmetry. Okay, similarly, these various special symmetry point groups also are indicated by D, H and V. Okay, for example, TD means a tetrahedral molecule with dihedral planes, but TH means something which has a tetrahedral symmetry but a horizontal plane of symmetry and no dihedral planes. Okay, similarly, if you just have T, this T would mean that neither dihedral planes nor horizontal nor vertical planes are present. Okay, so the D, H and V denote the presence or the absence of these reflection planes. So for example, OH is an octahedral point group with horizontal plane of symmetries, but if you remove all the sigma H, which is the horizontal planes, you get O. Similarly, in IH, icosahedral point group, the H stands for a horizontal plane of symmetry, whereas if you remove the sigma H, that is the horizontal planes of symmetry, you end up getting the I point group. Okay, and C infinity V will have sigma V, D infinity H will have sigma H. Got it? So these are the various types of point groups. Okay, now how do we identify these point groups? There is a very detailed procedure. There is a detailed method to figure out whether these point groups, whether the given molecule has certain types of point groups. So for example, if you have a linear molecule, you will only have C infinity V and D infinity H point groups. So the first question that you need to ask is it a linear molecule? Okay, the first question that you need to ask is whether it is a linear molecule. If it is not linear and no axis of symmetry either, okay, a non-linear molecule with no rotational symmetries, that will be part of either C1, Ci or Cs. Okay, that will be part of either C1, Ci or Cs. Okay, so then if you have a molecule which does have a rotational symmetry but no perpendicular C2 axis, okay, a non-linear molecule with a rotational symmetry but no perpendicular C2 axis, subsidiary axis, then it will be part of Cn, Cnv, Cnh or S2n. Okay, good morning Prasad, good morning. I'd like to request all of you to please share the link of this video on your maybe WhatsApp status or share it in your WhatsApp groups in which your friends who are preparing for the CSIR NET, GATE or even the IIT JAM exams. You can share the video, the link of this video on the group. If you look at this, if you look here somewhere, there is a share button right below. Okay, you can click on the button and you can simply share this link. And WhatsApp is not the only place. You can share on your Telegram channels if you have, Instagram channels if you have. In general, just please tell people about this English lecture series, because I think this is the only lecture series that is there in purely English on YouTube for specifically for CSIR NET June 2024. All right, so there are a lot of students who are preparing for the NET June 2024 exam, and if they struggle with Hindi, if they prefer English over Hindi while learning chemistry, please make sure that they attend this lecture series. This lecture series will continue throughout the year at 9 a.m. Or in the morning sessions every day, and you will find that it is extremely useful for all of you. All right, good morning Prasad. Okay, so we saw linear molecules with C infinity V, D infinity H. We saw molecules which are non-linear, which have rotational symmetry but no perpendicular C2 axis. Then they will have Cn, Cnv, Cnh or S2n, which is the C category of point groups. Okay, now for the D category of point groups, what do you need? For the D category of point groups, you need a principal axis and perpendicular C2 axis. Okay, you need a principal axis and perpendicular C2 axis. Okay, whereas if you look at the special symmetry point groups, tetrahedral, octahedral, icosahedral, then you need a rotational symmetry and you need more than one rotational axis of symmetry. What you need is more than one rotational axis of symmetry. Okay, so this is how, what you have to do is simply ask 4 different questions. What are these 4 questions? The first one is the molecule linear? The second one is, does the molecule have rotational symmetry? The third one is, does the molecule also have perpendicular C2 axis as the rotational symmetry? These are subsidiary axes. And the fourth one is, does the molecule have more than one principal axis? All right, so now based on this, in each of these categories, we have divided the point groups in 5 different categories. For each of these categories, what further questions do we have to ask in order to distinguish between these? That's what we are going to see. So linear, perpendicular, linear, then rotational symmetry, then perpendicular C2 axis, and more than one principal axis. Okay, so suppose it's we have linear molecules. What makes them C infinity V and what makes them C in, D infinity H? So D infinity H molecules have inversion as well as sigma H. Okay, inversion symmetry as well as the horizontal plane of symmetry. Notice how there is an H here, and the H means that there will be a sigma H. Alright, whereas C infinity V will not have a sigma H. So the moment horizontal planes of symmetry are absent, you know that it is not a D infinity H, it will be C infinity V. Okay, and we have seen various examples of these molecules in the last week, wherein we saw C infinity V are homonuclear diatomic molecules. Sorry, C infinity V are heteronuclear diatomic molecules, and you will also have asymmetrical linear molecules on C infinity V, whereas D infinity H are homonuclear diatomic molecules with homonuclear diatomic molecules as well as linear symmetrical molecules. Okay, all of them will be D infinity H. Okay, so you have linear molecules C infinity V and D infinity H. Okay, now the next type of point groups, low symmetry point groups. Okay, the next type of point groups which are low symmetry point groups. These low symmetry point groups will all have a rotational symmetry. Okay, all of these low symmetry point groups will have a rotational symmetry, C1, Ci and Cs. Okay, good morning Komal. But they will not have a perpendicular C2 axis. Okay, they will not have a perpendicular C2 axis. All right, so perpendicular C2 axis are absent here. Perpendicular C2 axis will be absent for the low symmetry point groups. Now, along with the rotational symmetry, which other symmetry elements are present, that will help us classify them into these three different point groups. Okay, so for example, you have I here, meaning inversion will be present. You have S here, S stands for sigma. Sigma means reflection will be present, inversion will be absent. And you have just C1 here, no I, no S, no H, V or D. It means inversion is also absent, mirror planes are also absent. All right, is this clear to all of you? Is this clear to all of you? Vaishali is asking, please help me for my confusion, but she is not telling me what her confusion is. Okay, let's wait for her to send what her confusion is. Okay, now before we proceed ahead, I again want to request all of you to share the video, share the link of this video on your WhatsApp status, on your WhatsApp groups, Telegram groups, Instagram, Facebook, wherever you can, wherever you feel it is okay. Okay, there is a share button right here. If you click on that button, you will get a link which you can post. Okay, all right, then let's look at the next point groups. High symmetry point groups. Okay, what are the different high symmetry point groups? Now, the C category point groups. There are two types of high symmetry point groups, C category and the D category. Okay, the C category point groups will have rotational axis of symmetry. Oh, hang on. I made a big mistake here. None of these have a rotational axis of symmetry. I'm so sorry. All the low symmetry point groups, none of them have a rotational axis of symmetry. I feel that none of you are paying attention because I wrote a tick mark here and no one is pointing it out. How is that possible? C1, Ci, Cs, none of them have a rotational axis of symmetry, whereas the high symmetry point groups all have a rotational axis of symmetry. Okay, all the point groups which have a rotational axis of symmetry, they are high symmetry point groups. Then, however, the C category point groups don't have a perpendicular C2. Okay, the C category point groups do not have a perpendicular C2. Okay, whereas now if you look at sigma V, sigma H and inversion, you will find that something is present there. Okay, for example, you have C and V, meaning sigma V is present and these will be absent. You have C and H, meaning sigma V will be absent, sigma H is present. Now, inversion is present in the C and H point group if N is even. Okay, meaning C2H, C4H, C6H, all of them will have inversion symmetry. All right. Whereas if you look at C3H, C5H, they will not have inversion symmetry. Okay, they will not have inversion symmetry. Now, how about Cn? Cn will not have sigma V, sigma H, or I. Okay, neither sigma V, neither sigma H, nor I, none of them are present. Whereas S2N also don't have these. Okay, S2N point group molecules also don't have sigma V and sigma H. Inversion, however, might be present in specific molecules. So, for example, if you have a S3, you will not have inversion. If you have a S4, you will not have an inversion. But if you have S6, okay, if you have S6, then you will have inversion. So N needs to be odd. Okay, meaning for S6 point groups, you will have inversion that is present. Okay, meaning for S6 point groups, inversion has to be present. Is this clear to all of you? Is this clear to all of you? Okay, Vaishali is again raising a hand but not telling me what her confusion is. Vaishali, please tell me what your confusion is. Until and unless you do, I won't be able to help you. Alright, simply asking for help is not sufficient. Telling us, communicating to me where you need help, that will help. Okay? Alright. And I am noticing that none of you are liking this, whatever we are studying. I feel that I start feeling that maybe I'm not doing a good job. I'm not teaching very well. Alright. So what should I do? What should I do? I have sent a message. Okay, Vaishali, can you send your message again? I can't see your message. Just send your message again rather than repeating the same things over and over again. Okay, fine. Because even I am needing your help to understand what your confusion is. So I need your help. Just tell me what your question is. All right. Okay, let's go ahead. Let's look at the D category point groups. Now, these are again higher symmetry point groups. Okay, wherein rotational axis of symmetry are present, meaning there is a principal axis, whereas perpendicular C2 axis, they are absent. They are also present. Perpendicular C2 axis, they are also present. Okay, if you like the content that we are studying here, if you like the way of this particular way of studying point groups, studying symmetry, make sure that you like the session, make sure that you like the press the like button, so that I get motivated when a lot of students are press the like button, because it tells me that what I'm doing is correct. I'm doing a good job. You are understanding everything that I am everything that we are discussing here. Okay, now how do you differentiate between DN, DND and DNH point groups? So let's start with DNH. Sigma H has to be present. Okay, DND, sigma H is absent. Okay, because there is a DND. Now, whenever you are trying to figure out what the names of these point groups are, the H, that is the sigma H, the horizontal plane of symmetry, always gets preference. He is the older brother, whereas a D and D, sigma D and sigma V are the younger brothers. Okay, if sigma H is there, they always get preference. Okay, the older brother will always get the preference. So similarly, whenever you have sigma H, you will have H in the name of the point group. However, here in DNH point groups, you will notice that sigma V is also present. Okay, or to be more precise, planes passing through or planes parallel to the principal axis are also present. Okay, now what does that mean? What does that mean? So here you don't have sigma V, you only have sigma D. Okay, in the DND point group, okay, in the DND point groups, you only have sigma D. Okay, these are dihedral planes which bisect the C2 axis. Okay, these are the vertical planes which bisect the C2 axis. Vaishali, I have sent third time my message. Vaishali, I can't see your message. Stop wasting my time. If you don't want to post it again, don't post it. Okay, but stop sending these messages on the chat box. If you actually have a question, just post the question. Stop requesting me to see your message or answer your message. Just tell me what your question is. Okay, all right. This is sigma V and sigma D. Okay, now if you look at D and H, if you look at the D and H point group, a D and H point group will sometimes have sigma V also, sometimes have only sigma D. Okay, so for example, if you look at D3H point group, that is BCl3. Okay, if N is odd, so here we have something different. If N is odd, then we have N by 2, we have all N sigma V's. Okay, so for example, D3H, you will have 3 sigma V. D5H, you will have 5 sigma V. All right, but if N is an even number, okay, if N is an even number, and then sigma V, like for example, D2H or D4H or D6H, then half of the planes that are parallel to the principal axis are vertical mirror planes, whereas half of the mirror planes are dihedral mirror planes. Okay, half of the planes are vertical mirror planes, half of the planes are dihedral mirror planes. Okay, Vaishali, was that so hard? Only IFAS books and your notes sufficient for the exams, or reference books also must for the exam? Okay, that's a good question. A lot of students ask this question, so I'll give you a very simple answer. Reference books, you don't have time to study reference book. Reference books are the best books. You do not have time to study reference books when you are preparing for the exam. Like for example, the next CSIR net exam is in December, most likely on the 27th of December. And if you start reading, let's say if you want to study physical chemistry, if you start reading Atkins for the next 2 weeks, you will not even complete one chapter there. Okay, though Atkins is the best book that's available for physical chemistry. All right, so the reference books are not really what we are looking for. All right, when we are preparing for the entrance exams. But when you are studying for your masters, when you are in your first year of MSc, second year of MSc, or even when you are doing your BSc, you should read reference books, because reference books will give you a very different understanding of the subject, whereas IFAS books are meant to crack the entrance exam. We know which questions are asked, which topics get more weightage, and we have only included those topics in the reference book so that you can have a targeted, a focused preparation towards the entrance exams. Okay, so IFAS books and our notes are absolutely sufficient for cracking the entrance exams. However, when you want to study the subject further, once you crack the entrance exam, you should continue using the IFAS theory books. They will be great. And you should start reading reference books. The reason why I say that IFAS books will be sufficient is because we have referred the reference books for you, and we have taken all the important concepts of the reference books and put them in our IFAS books. So instead of reading 10 different reference books for one book for each topic, you can just read the IFAS books. That's just one book, and you will cover all the remaining topics there. Okay, so that is the biggest advantage of IFAS books. Okay, Vaishali, does that answer your question? All right, Abra is asking, sir, WB set one question group theory. All right, Abra, I don't know what the question is. So, but because we don't have the paper, if it is possible for you, can you just send the West Bengal set paper on our Telegram group? We'll try to discuss the entire paper on the Telegram group on YouTube. Okay, Abra? So we have a Telegram group. You can just go search IFAS chemistry on Telegram. IFAS chemistry. Just go search IFAS chemistry on Telegram. And please, it must have been a paper-based test. Just send us photos of that entire paper, and we'll discuss the entire paper. Okay, so don't worry. It's just that I didn't have your paper, so we'll discuss it here. All right. Okay, great. No problem, Vaishali. No problem. Just remember, can I ask you a question is a question itself. So don't ask that question. Directly ask your question. It saves time for both of us. All right, that's the simplest thing. And make sure that you don't, you always ask questions, you always ask doubts. There is nothing wrong in asking doubts. Just ask doubts the right way. Be very specific in the doubts that you are asking. Okay, So Abra, please send the West Bengal set question paper on our Telegram group today. Okay, we'll be very happy to discuss the entire paper on YouTube here. Okay, all right. Okay, so let's go ahead then. So these are all, these were the D category point groups, wherein you will have sigma V and sigma H in D and H point groups, whereas in D and D you will only have sigma D point groups, no sigma H. Okay, and in DN you will not have either of them, no sigma H, no sigma V either, which is why inversion is also absent. Now you must be wondering why I am why I did not mention inversion here, because again inversion is complicated. In D and D, inversion is present when n is an odd number, whereas in D and H, inversion is present when n is a even number. Okay, in D and D, inversion is present when n is odd. D3D, D5D have inversion. Okay, but D2D, D4D, D6D will not have inversion symmetries. Okay, whereas in D and H, it's exactly opposite. N needs to be even. So D2H, D4H, D6H have inversion. D3H, D5H do not have inversion. Okay. And finally, you have special symmetry point groups. For special symmetry point groups, always start with whether inversion is present or even horizontal mirror plane is present. Though in special symmetry point groups, I can understand that you will think that instead of inversion, why not sigma H? These two have H. This doesn't have H. So if horizontal plane of symmetry is absent, then we'll declare it as tetrahedral. But don't do that, because here, because there are more than one principal axis, whether the plane that you are talking about is horizontal or dihedral or vertical can be slightly tricky. Okay, so instead of that, inversion is a very good indicator. Octahedral and icosahedral point groups will have inversion. Tetrahedral point group does not have inversion. So if you have a molecule which has more than one principal axis, okay, if you have a molecule with more than one principal axis, then if inversion is absent, tetrahedral point group is present. Okay, that is the simplest way to figure it out. And then how do you differentiate between octahedral and icosahedral? Because both of them have inversion. Then look for C5 rotational axis. If C5 rotational axis is present, then it will be an icosahedral point group. If C5 is absent, it will be an octahedral point group. Okay, and of course tetrahedral does not have C5. So this way, once you have classified whether it will be a linear molecule, whether it will be a low symmetry point group, whether it will be a C category point group, whether it will be a D category point group, or whether it will be a point group with special symmetries, look for sigma H, look for sigma V, look for inversion, look for specific rotational axis like C5 in special symmetry point groups, and then you will be able to classify according to each point group. Okay, is that clear? Is that clear to all of you? Is that clear to all of you? Any doubts so far? Buckminster-Fullerene is icosahedral point group. We have discussed it in the last class. So Fullerene C60 is here. Octahedral will have all mx6 octahedral complex without, especially those without Jean-Taylor distortion. Okay, and tetrahedral is essentially tetrahedral molecules like CH4. Okay, is that clear to all of you? Is that clear to all of you? All right. Okay, now let's go to polarity and chirality, our discussion of polarity and chirality. But before that, let me remind you that a new special live batch is starting from the 18th of December, meaning today. Okay, a new live batch is starting from today, 18th of December. This is a live batch that is aimed at CSIR Net 2024. The syllabus will be completed by the month of May, and in June we expect the next CSIR Net exam to be conducted. So in 5 or 5.5 months, the entire syllabus of CSIR Net will be covered, and you can prepare for the CSIR net exam a month in advance, because most of the students, they are going to start their preparations sometime in January. Okay, there will be students who will just qualify December 2023 exam right away. Okay, there will be some students who will miss the exam, because only 2% students, typically 2% of the students who appear for the CSIR net exam qualify, and the remaining 98% who have not qualified will of course attempt the CSIR net exam once again. All right, they will take rest, right? Because on the 27th of December, if the exam is there, then for a week they will relax. They will say that, okay, I have studied a lot, now I want rest, I want to relax, and they will start their preparation again in the month of January. And again they will say that, okay, we have attended a live batch, we have all the notes, what is the hurry, let's start studying in February. And then February becomes March, March becomes April, April becomes May, and by the time you have April, everyone has received the notification for the June exam, so they will now start preparing. Okay, you don't want to become that, you don't want to be part of this crowd. What you want to do is start preparing as early as possible. Okay, there are a lot of students who are appearing for the December exam. They know that they have not been able to prepare very well. They will need one more attempt to crack the CSIR net exam. Those students should immediately enroll for this particular batch. Okay, because if you keep postponing your preparation, if you keep postponing the time at which you start your preparation in a very systematic way, you will suffer. Okay, you will start preparation once the notification comes. After 1 week, you will again feel that we will not prepare. Start preparing right away. Start preparing 1 month before all the rest of them are going to start. Okay, all the serious students are also going to start in the month of January. So because they are serious students, they will crack the CSIR net exam. But I want you to also become serious students and enroll in this batch immediately. Okay, this is, note that because this is an English version lecture series, note that this is a Hindi plus English medium batch. Okay, so it's a live batch. The teachers will be speaking in Hindi, but all the notes are in English, so you will understand all the chemistry that goes around there. All right, and of course, anytime you don't understand the Hindi, just raise your hand, ask us to repeat in English, we will repeat in English. Okay, that's the very simple way in which these batches proceed. All right, and the batch is starting on 18th of December, which is today. Apart from that, there is a special test series, a complete CSIR net test series with topic wise tests as well as full length mock tests. That will be at we have reduced the price. It's now $199 only. You merely have 1 week remaining for the exam, or 10 days remaining for the exam. You do not have time to waste. If you have not started taking practice tests, go enroll in this series and start solving practice tests immediately. The price is very, very affordable. It's not even 200 rupees. Okay, so right now is the correct time, and we are shortly going to start special prime classes for the CSIR net December 2023 and June 2023. These are free live classes in our app. Okay, and these live classes will also so you will learn chemistry, of course, but they will also help you get a feel of what the app is, what the features, what are the different amazing features that our app has. And I'm sure that after that you will just come and start preparing with us. And finally, there is a English version lecture series that of course you know. Okay, also apart from that, up to the 31st of December, we are running a special offer that the entire set of study material for chemistry is available at a flat 50% off, and you can get this complete set of 13 books at 5,250 only. Okay, now let's look at polarity and chirality, or more precisely optical activity. Which point groups will be polar? Okay, which point groups will be polar? So point groups wherein perpendicular C2, okay, the point groups wherein perpendicular C2 is absent, sigma h, that is a horizontal plane. Okay, so the rotational axis can be present, but horizontal plane of symmetry is absent, and inversion must be absent. Okay, so perpendicular C2, sigma h, and inversion must be absent. And if that happens, then these molecules are polar. Okay, which means if perpendicular C2 is present, polarity is lost. If sigma H is present, polarity is lost. If inversion is present, polarity is lost. The molecules will become non-polar. Okay, is that clear? All right. And then if you look at which point groups, so which point groups don't have perpendicular C2 or sigma H or I, then there are 5 different point groups which don't have them. C1 doesn't have it, CS, Cn, Cnv, C infinity V. So these 5 point groups, molecules belonging to all these 5 point groups, are always polar molecules. Okay. Now notice, one might think that this is CS. CS has a reflection plane. We have said that reflection plane must be absent. Okay. So for a molecule to be polar, reflection must be absent. This has a reflection. Note that sigma is not sigma H. Okay. In CS point group, the reflection plane that is present, that is not the sigma H point group. Okay. In CS point group, the reflection plane that is present is not the sigma H point group. That reflection plane is in fact the is just a reflection plane. For it to be called sigma H, you need to have a principal axis. Okay, if you have a principal axis and a plane perpendicular to the principal axis, then it becomes sigma H. But if you don't have a rotational symmetry, the plane that is present has to be just sigma. It's neither sigma V, nor sigma H, nor sigma D. Okay, so this is the first thing that you should notice about CS point group, and which is why even though reflection symmetry is present, it is not polar. It is polar in nature. Okay. Similarly, in case of optical activity, what should be there in case of optical activity? That is, SN must be absent. Okay, any improper rotation must be absent, and finding improper rotations can be tricky. So instead of searching for improper rotations, we can simply search for I and sigma. Okay, most of the commonly asked molecules, they will be optically active simply because I and sigma are absent. Okay, but if you have point groups, if you have molecules from the SN or S2N point group, they are optically inactive because SN is present, but I and sigma are also absent there. Okay. Now, where do we have improper rotations completely being absent? There are only 3 point groups where it is true, which is C1, Cn, and Dn. Only these 3 point groups will not have the SN operation. All right. So only molecules from C1, Cn, and Dn are the ones that are optically active. All the rest of the molecules are optically inactive. Okay. Remember, for example, there are also meso compounds. Meso compounds have chiral carbon atoms, but they have a reflection plane. And because of the reflection plane being present, the molecules are optically inactive. All right. So remember these operators. Now, if you compare all of the point groups, so C point groups, molecules from the point group C1 and Cn, they are polar as well as optically active. Molecules from CS, CnV, C infinity V, they are polar, but they are optically inactive. Similarly, there is a point group which is non-polar but optically active, that is the Dn, and all the rest, they are neither polar, non-polar, and optically inactive also. Make sure that you take a screenshot of this table. Okay, just take a screenshot of this table. This table is extremely makes it extremely easy for you to figure out whether a molecule will be polar or optically active. Okay, this will make it extremely easy for all of you. Just take a screenshot of this table. Okay, simply take a screenshot of this table. Once you have taken a screenshot, just let me know in the comments so that I can continue. Once you have taken a screenshot, just let me know in the comments that you have done. You have taken a screenshot. This is a very, very important table. You get easy part B questions, easy 2-mark questions, wherein a molecule is given and then they are asking you whether it will be polar or optically active and so on and so forth. Okay. Have you taken a screenshot? Done? Prasad? Great. How about the others? Vaishali, Abra, Prasad has done it. Komal, Deb, Ankita, Bhargavi. None of you have interacted. None of you have said anything in this session. And I think Megha is also there every day, but she is absent today. Okay, done. So let's look at a few examples of this. So I am drawing three different molecules here. What you have to tell me is which of these are polar and which of these are optically active. Okay, so there are three different molecules here. There are three different molecules here. You have to tell me which among these are polar, which among these are optically active. Okay, so this is the question. All right, if you look at that particular molecule, that molecule has been asked in the CSIR net exam. The point group of this molecule was asked in the CSIR net exam. The rest of them have not been asked. I have made some new molecules just so that you can have some fun. You can figure out whether it is optically active, polar, non-polar. All right. So can someone tell me what will be the point group of the first molecule? So you have three molecules. This is the first. This is the second. This is the first molecule. This is the second molecule. And this is the third molecule. Try to tell me what the point group of the first molecule is. Okay, what is the point group of the first molecule? Now, remember the four questions that we said. The first question is, are they linear? So none of them are linear. The molecule is not linear. Does it have rotational symmetry? Yes, absolutely. It does have rotational symmetry. If you look at this axis, this is a C2 axis. Okay, if you look at this particular axis, it's a C2 axis. So there is a rotational symmetry present here. Is that, can all of you see this? Can all of you see the rotational symmetry present here? Yes. Okay, great. So which means it will be either C category, D category, or high or special symmetry. Okay. Now let's look at perpendicular C2 axis. Will this molecule have a perpendicular C2 axis? So look at, this is one axis. Look at an axis which is perpendicular to this. So suppose we make an axis pass through these 2 points. Suppose we have an axis which passes through these 2 points. Suppose we have an axis which passes through these 2 points. Okay. Is this axis a C2 axis? Absolutely. This axis is also a C2 axis. Remember what we said about molecules that look like S, N, or Z? Look at this part. If you look at this part, you will immediately notice that this is something like an N or a Z. Okay, a rotated Z. All right, which means there will be a C2 axis like this. Which means there definitely will be a C2 axis like this. Okay, is this clear? Oops, sorry. And now, do we have a reflection plane? Okay, so you have you have a rotational axis, C2 is present. You have perpendicular C2 axis, and when you have perpendicular C2 axis, what does that tell you? Perpendicular C2 axis meaning it will be a D category point group. Okay, now among the D category point group, the first thing that you have to see is whether there is a horizontal plane of symmetry. Now, if this is the principal axis, the horizontal plane will be these four, the plane formed by these 4 carbon atoms. That is not a plane of symmetry, because notice that you have a you have a X up here, but you don't have a X down here. Meaning, if you reflect along the horizontal plane, it will not work out. Okay, so then this will not have a horizontal plane of symmetry, which means it is either DN or DND. So now here we just have to figure out whether there is any reflection plane, and the answer to that is yes, there is a reflection plane. The answer to that is yes, there is a reflection plane, which is this particular plane. Okay, if you look at this particular plane, it is a reflection plane, meaning it can't be dn, it cannot be dnh, because there is a horizontal plane. So can someone tell me the point group of this molecule? Can someone tell me what the point group of this molecule is? Good morning, Adesh. Can someone tell me the point group of this molecule? The point group of this molecule will be D2D. And where does D2D come? If you look at this table, there is no D2D or there is no DND here, meaning DND will be here. It's neither polar nor optically active. Okay, so it is neither polar nor optically active because it is a D2D point group. Is that clear? Very good, Prasad. Very good. Absolutely correct. Okay, now let's look at the second molecule. This molecule also has a rotational axis of symmetry. This molecule also has a rotational axis of symmetry. Okay, this molecule also has a rotational axis of symmetry. All right, is that clear? And a perpendicular C2 axis, however, is absent, because now if you look at this particular part, you have x here and you have a y there, meaning now it doesn't represent, or it doesn't look like a n or z or an s. So the perpendicular C2 is absent. However, the reflection plane is vertical. The reflection plane is vertical. Okay, the reflection plane is still vertical. So if you have a C2 axis, no perpendicular C2, and you have a vertical reflection plane, what will be the point group? The point group will be C2V. The point group will be C2V. And what do you know about C2V? So if you look at the if we look at the C and V point groups, okay, if we look at the C and V point groups, they are polar and optically active, optically inactive, which means this point group will also be polar but optically inactive. Okay, this molecule will be polar but optically inactive. Is that clear? Very good, Prasad. Absolutely correct. Absolutely correct. Polar but optically inactive. Okay, and now if you look at the third point group, third molecule here, if you look at the third molecule here, the rotational axis is slightly different. Okay, here the rotational axis is slightly different. This particular vertical rotational axis is now absent because the x will get rotated into y. So that is absent. The axis of symmetry that we have is this one. The axis of rotation that we have is this one. This is the C2 axis. However, all of the reflection planes have been lost. All of the reflection planes are lost. They are not present here. And if reflection planes are not present, but a C2 axis is present, what is the point group? The point group will be simply C2. The point group will be simply C2. And if it is C2, it will be polar. It will also be optically active. For point groups CN, molecules are polar as well as optically active. Is that clear to all of you? Molecules are polar as well as optically active. Okay, is that clear to all of you? Is that clear to all of you? Okay, so this is how you first figure out the point group, and then you can refer to this table. This table will tell you whether it is optically active or optically inactive. Okay, is that clear? All right, so let's stop today's session here. All right, now I want you can see many different students here, photographs here, and more than 1,000 students had qualified from IFAS in the last exam, June 2023 exam, and we want all of you to also be part of this entire list. Okay, so what we have done is, for you to practice, we have given free access to the entire set of all previous year question papers. You will notice that If you go to the CSIR website, all the previous year question papers are not available there. You have to search really hard, and your search is now over. All of these papers are now available on our IFAS website itself. You can just simply go and register on our website, and you can even download these papers in PDF format and solve them. Okay, so this will be great practice for the CSIR net exam. Okay, so or the other thing that you can do is just download the IFAS app, register on the IFAS app, and then you can have access to those previous year question papers. Okay, so thank you for joining me in this lecture. AKD is saying one-shot lectures. One-shot lectures are actually starting today. Okay, you will have inorganic chemistry and organic chemistry one-shot lectures starting from today, and they will be marathon sessions. Okay, they will be at least 3 hours every session, and you don't need to study throughout the day. Just join on the IFS channel at 5 o'clock in the evening, and at 5 p.m. in the evening you will be able to attend one short series. 5 p.m. is inorganic chemistry, and 9 p.m. at night is organic chemistry. 9 p.m. at night is organic chemistry. You will have one short series throughout this week. Physical chemistry one shot sessions we have already had earlier. We have studied a lot of other topics in the exam mapping session also. I'll also be uploading a few videos so that you don't think that we are not getting any revision of physical chemistry. But make sure that you attend these one shot series every day. This will cover the entire syllabus of inorganic and organic chemistry. Just if you go to our channel and if you go to the upcoming lectures, you will see that all the topics from the syllabus are covered in this one shot series. Okay, so make sure that you join in the evening also for a complete revision of the CSIR net inorganic chemistry and organic chemistry syllabus. Okay, so goodbye everyone, and I'll see you in the evening. Until then, happy learning and all the best. Okay, make sure that you attend the 9 o'clock lecture tomorrow also for a fully English medium group theory, wherein we are going to study another very crucial aspect of group theory, which is applications of point groups, which is character tables. Okay, once you understand character tables, all the rest of the topics become much easier for you. Okay, so let's stop here for today. We'll continue our discussion of group theory in tomorrow's session sharp at 9 o'clock. Until then, goodbye and happy learning.